Thank you, gentlemen, for the introduction and running the poll. So I welcome you all to this webinar. So where today we are just going to focus more onto the BIM for structural engineering. So we're going to look at the different solutions and the cloud collaboration platform that Autodesk has provided us with that we can utilize within our structural engineering workflow. That is on how we can also collaborate with the different design team where we are working in a multidiscipline team setup. So just as a start, we'll go through first the various industry challenges that we are facing currently as structural engineers, and then we'll look at the various workflows that we propose using the different Autodesk tools for BIM, for structural engineering. Then after that, we'll go deep into some of the various software one by one that you can use for design at different stages within the design process. That's basically starting from when you receive maybe an architectural model, or if you're starting to do your 3D structural model from scratch. So basically, when looking at about BIM for structural engineering, basically look at an integration that starts from the conceptual design, going through up to the fabrication and construction of the design that we are doing. So more or less, it's what we refer to as a connected BIM, because all the entire design process is going to be one and the same thing, which is interconnected using various design platforms as provided by Autodesk. That is including the tools that are available within the AEC collection, going through up to the BIM 360, and which is the cloud collaboration platform. So from our poll, I saw that a number of us are working as structural engineers, and most of us are also currently using other products to do their collaboration. So basically, I think it could be where we collaborate via WhatsApp. I know people collaborate on projects where they share documents or progress and request for different information from their design team using WhatsApp groups. Also, there's the use of platforms like the Google Drive, the Dropbox, or WeTransfer to share different design documentations. But in this case, we're looking at a more advanced cloud collaboration platform like a BIM 360 that basically joins and connects the entire design team. And before that is done, basically we need to have our design models or documentations in place. So we'll just basically going to look at how we as structural engineers can implement such high level of connected BIM when delivering on our different projects. So I said that we look at the challenges that we face in the industry as structural engineering, where I say that first, just to give us a quick recap on what maybe a structural engineer is, or what a structure itself is within the architecture, engineering, and construction. So we know that structural engineering forms a very integral and important part within the process of delivering a project, in that it forms a very critical part of a building or any structure which is supposed to be constructed, irrespective of where it's going to be. So structure basically is the critical part of that building, which ensures the safety and comfort of the occupants of that particular building which is going to be constructed. So by cost, we know it constitutes approximately 10% of the cost of the construction. And it's what's basically being done on site first, because we know that the first thing which will happen on site when building maybe a residential building, commercial or hospital, is to first do your technical investigation and put up the foundation which is going to support that building. So structural part forms the first component of the building which will be put in place on site. So structural building are usually done by, structural component of the building is done by at least 14 structural materials. And the most commonly used here in our continent is reinforced concrete. But we are also seeing the advent and increased use of structural steel, though it's still not very, very commonly used in different parts of the continent. Also, we are seeing also emergence of the use of offsite or prefabrication, where a number of different clients are now proposing prefabs, or where first, like some countries are reusing things like maybe the panels, the the prefabricated panels, so you just come and install them on a site where they have already been cast somewhere on the site, on site, or on a warehouse somewhere. Then you come and just install them on the construction site to just help on cutting on the cost and time of delivering the project. So that's just an overview of what structure is and how it forms a very important and integral part of the overall AEC industry. So in terms of the challenges that we face, we know that the projects we are currently delivering on different parts of the continent are becoming more complex. So like different architectural design, which are quite complex for us as structural engineers to deliver on. Also, maybe in overall infrastructure design, where we have architects specifying for us various complex bridges, architectural layouts for the building, that you have to ensure that when delivering the same, when you're providing the structural for the same projects, we have to ensure that we meet all the different aspects that the architect have also specified on that particular project. So the complexity of the project that we work on nowadays is very, very much increased compared to what people used to maybe deliver on in the previous decade. Also, we are facing the problem of the disconnection between the design and detailing. So basically, this is where, when delivering on a structural project, we find that we don't work within the same platform to deliver on our design and detailing, where people opt to use a different tool to do their design. And most of us, I can say, are still doing manual design. And then when detailing, we go to maybe the basic AutoCAD and start doing our 2D layouts or the GS on that 2D platform. But that disconnection usually results into loss of information. And also, it's not very easy to understand and convey the design intent to the contractor to ensure delivery and the implementation of what we have designed on our platform as structural engineers. Also, the need to diversify the materials. So as I said, that we saw that we are having at least 14 different construction materials that we use to deliver on our structural projects. So as I said, that there is usually pressure on concrete because it is being extracted from natural materials, which I'm very sure with time will be maybe under pressure, will be facing will not be adequate enough to deliver on the same and increasing number of projects to be done. So if there is need to diversify onto the different construction materials, it means as structural engineers, we need to also start learning and knowing on how to design using these different structural materials, as opposed to just knowing how to design on structural steel, and also reinforced concrete. So there's need to maybe think of the composite materials, like a composite between timber and concrete and steel, and just to ensure that we help the client to deliver the project within the required cost. Also, the need to cut on waste. We realize that construction right now is one of the one of the industry which is very, very inefficient in terms of waste reduction, and also ensuring that we implement within the required budget, because we realize that most of the projects are always delivered when the cost of the project is already way above what was projected. So we can help the client and different developers by ensuring that when we design, we propose prefabrication, where if they go to install them on site, there will be very minimum wastage. And this basically leading us towards what you call the green building, and also using the LEAD to ensure that we cut on our waste and just towards the green environment as well. So those are some of the key challenges and problems that we face in the industry today. And also, apart from the challenges that we face when delivering the project, there's also the changes and opportunity within the industry. So before, we only used to have structural engineers and structural retailers. But with the advent of the BIM and this latest trend and technological development within the construction industry, we find that people tend to diversify, and also we tend to look at specific skills when delivering on some projects, where maybe the client will specify that we want the project to be delivered within a BIM environment or BIM platform. In that case, basically means that we need to integrate a BIM specialist within our team. So basically, it's no longer having just the engineers and the contractors or the structural detailers, but we now need to look at integrating different specialists within the workflow, just to ensure that we enhance and speed on the delivery of the project based on the specific requirement that the client or the architect may impose on us when we start to deliver the project. But the main aim of this is just to ensure that when we extend such services, we will be more efficient and more, will increase the speed and time that we can deliver the project to ensure that we meet those different project scope and the TOR that may be provided by the client. So this is just giving us the overall overview of the various construction materials that I had mentioned earlier. So you can see basically when talk about the foundation, in many cases usually done using a reinforced concrete, but sometimes you may also think of incorporating the structural steel element where you talk of doing the base plates and what have you. But concrete, I think, is the most commonly used structural material for foundation. Then there is the structural steel, timber, cold form steel, metal deck, usually requiring the various plates. So I'm very sure most of the structural engineers in here might have used 2 or 3 of those different structural materials that are used commonly in the construction. So when talking about still within the structural design process, we are looking at different structural team members. As I said that with the changes in the technology and the advent of the BIM within the construction industry, we see that the role changes, and we find that someone who was initially just purely a CAD detailer may now need to maybe look at how he can integrate, apart from just working on the 2D platform, and also start looking at knowing exactly what are the various BIM processes and how does he work from maybe doing conceptual design, going through up to the detail bit, apart from just doing the normal CAD drafting that most of them were quite conversant with. So with those changes, we realized that the industry now integrates different personas when it comes to the structural design. So basically you have the overall structural engineer, who is just like kind of the overall project engineer in terms of ensuring that the system, the frame that are selected for that particular project met all the design requirements in terms of robustness and what have you for that particular project in question. Then the designer may now come in terms of ensuring the cost and the bidding for the tender purposes are all within the required design parameters. Then you have the detailer, who in this case is not just the normal drafting person who does our shop drawings and ensure that the drawing meets all the minimum standards and coordination for that particular case. Then the fabricator may come in terms of ensuring overall project management, production, planning, and assembly. So in this case, where we're looking at a project which is going to be, we are going to use prefabs in that particular scenario. Then out there in the field, the construction team may also have their field layout and direction, plus installation guy, who just ensures that whatever was designed and prefabricated is installed in the same way, just to ensure that we minimize on the cost and also on the risks that may be associated with that particular project. So those are some of the various personas we may be looking at when talking about the structural engineering with respect to the various changes that happens in the construction industry as of today. So most of these, the design process usually are already within the design phases, that is from the engineer going through up to the fabricator, we find that various BIM processes or workflows are already integrated. But when moving from the office to the site, there's usually some broken non-BIM workflows which are still very efficient. And that's what the purpose of this demonstration today will just try to emphasize on, showing that not only should we just stop our BIM workflows within the office, but we can still extend the same to the construction phase and even integrating the overall design team, that's the architects, plus even the MEP engineers. So just as with the focus to the structural designer, which many would be wondering what's the difference between a structural designer and a structural engineer. So as I mentioned that if correctly applied, the structural engineer will basically focusing on the structural robustness, selection of the structural material, deciding on the specific design parameters that will be used to deliver on that particular structural project. But the structural designer now comes in to collaborate within that entire design teams in terms of ensuring that the structural system concept, the design of the structural layout, detailing of the structure, documentation, and material takeoff, that is in the terms of the quantities or the BOQs that are going to be generated, are all produced within the required timelines and also with respect to the cost that the client is looking at. But as this is a new role which different people are still struggling to include, that position still struggles with different challenges that they face within their workflows. So being in between different design disciplines, like trying to ensure that their structural layouts or structural elements are within the required architectural parameters. The rework due to changes by other disciplines, like maybe the MEP doing a duct which is cutting through their beam, and they need to ensure that those beams are not interfered with in terms of their structural integrity. Also, they need to collaborate with the external stakeholders like the client, different construction methods within different parts of the world. Also, the inaccuracies that may result for those who still work within the CAD environment, that's the normal AutoCAD. And also the creation of the MTOs on time. So that's just again an overview of what a structural designer may look like in terms of the role that he plays, and also what he currently still faces when delivering on his position. So the same even applies to the structural engineer. So where most of us are really said that design depending on the frame, structural design parameters, structural material, the performance against the local codes. But again, doing this with the current tools that we currently use is still a challenge to the structural engineer himself, because the project may be very complex, that delivering on the required structural project using the normal CAD standards that we use is still a challenge to them. So with that overview, we can now look at what we propose as of today in terms of connected BIM, and different people within different parts of the continent and the world at large already uses these to deliver on their projects. So when looking at a BIM workflow with respect to the changes and cost, we know that we aside mentioned that the structural component of the project constitutes up to about 10% of the cost. But this cost can sometimes shoot up to even 20% as a result of improper design, or maybe the reworks that may occur when there is no proper coordination and collaboration between the entire design team. So if the structural designer or the structural engineer do not engage the entire team at the early stages, that's likely to be a challenge or will result into an increase in cost. Also, the need to do prefabrication and installation may also result in an maybe increase in cost if there was no proper coordination and just proper understanding of the entire design process within the entire design team. If that collaboration did not come out correctly during installation of the prefabricated parts where such is being done, may result into a problem in its own. Also, delivering on accurate details, if you don't do proper coordination with the entire design team, that's also a challenge that the team may face in the overall project cycle. So the same even applies at the installation phase, where there is no proper coordination and back and forth communication between the contractor and the structural team. We are likely to still face problems, especially where the project is very, very complex. So poor coordination with other trades, the owner receives incomplete as built. Those are still the issues that the industry are currently facing. But in this case, we are now proposing, with what I'm going to show you, a connected design and construction process where whatever is designed is basically what we translate into the construction phase, where we just integrate the contractor's team within the same platform that we use to collaborate and share our design data within the design workflow. So as I mentioned, in this case, we are basically focusing at the different tools that Autodesk proposes or provides us with that we can integrate within our design process to ensure efficient delivery of the project. So looking at the screen right now, you'll be able to see a number of products that we propose, starting from the point when you receive an architectural model and you want to create your structural model from it, going through up to the point where you can do prefabrication and installation of the same. So the ones which are on the green, or which are on the red rectangle, are basically grouped together into what we refer to as the AEC collection, that is the Architecture, Engineering, and Construction collection. So we find that at the start of the project, we basically need to look at something we refer to as the Autodesk recap. And this comes in place where we are looking at as-is situations. So So maybe the project could be requiring modeling of an existing building somewhere or just capturing the site condition. So in that case, you may use different equipment to capture the site in terms of maybe 3D laser scanners or drones. Pickup then will consume that data to convert into a design model that you can understand as a structural engineer. But cutting through all those design phases for a structure is Revit, which basically is the BIM platform that brings in the multidiscipline team together. But also we have the one that structural engineer will find quite relevant and important to them in terms of their analysis is the robot structural analysis, and plus a number of other products within that particular process, as you can see on the screen. But the top of that list is the BIM 360 products, which are basically enhancing the project delivery in terms of coordination and collaboration by integrating the entire design team, that is, plus even the external consultant that are involved on delivery of that particular project in equation. So we look at basically how we would work with these products to deliver on a structural design process. So the benefits of using this tool basically will result into collaboration, where you'll be able to collaborate in a dynamic environment. You'll be able to reduce errors in shop fabrication, and you can also extend that design process into the design process of the fabricated elements to the field, where, as I mentioned earlier, is the same data that we use to design, whether it is in 3D or 2D, that it translates into the data that the contractor will now use to implement the project on site. So it still has a number of benefits, but the one I can look at as of now for the specific designers within the workflow that we are looked at is basically in terms of collaboration within a dynamic environment, on and offline, and also the fact that you'll be able to reduce the errors because you can identify errors at earlier stages of the design process without leaving them to be identified during the construction phase. So a number of workflows are proposed when working with the tools that I've mentioned up on the previous slide. So we have the first workflow, basically we're looking at connecting the insight. So insight in terms of what you propose to deliver on as a structural model. So basically we integrate the BIM and analysis together. So in this case, we're looking at the structural model, the analytical model, plus the entire 3D model that encompasses the various structural elements together. Then after that, you now start connecting the various design team for the, whether it's concrete design or steel or whichever material you're looking at. Then after having connected in terms of the various elements you're looking at, you can now start bringing the multidiscipline team. So it means you first start by proposing your various structural elements, then you integrate the entire team, including the architects, the MEP, the QSSs, even the client can be integrated within that collaborative platform to start looking at what they will be able to have as a structural model. Then after that, you now start connecting your outcomes. And the outcome that you are connecting people to in this case is an optimized structural model which is constructible, meaning that you have identified issues in terms of constructability issues, the clashes that are likely to occur between your structural model and the corresponding architectural and MEP model. Then you now look at how to deliver the project. So we have those various workflows that can be separated or divided into different pieces of works, integrating different design team at different stages within the design process. So we look at each of them one by one. So where we first start with the connecting the insight. So I'll say that connecting the insight, basically looking at where the structural engineer and the structural designer now look at what they want to deliver to the customer in terms of the various structural elements, the frames, which should be robust in this case, the various structural materials they're also looking at in terms of whether it's going to be concrete, reinforcement, whether it's going to be composite, and basically this is also going to be guided by the available construction material in that particular region, and also what was recommended by the architect in many cases. So the structural designer, as I mentioned, will first create the physical model, including the analytical model. So that's in terms of the properties of maybe the boundary conditions, the support conditions, and what have you. Then after that, it shares the model with the structural engineer. So as I said, that the structural engineer is the one who will now play the role of verifying that whatever is provided by the structural designer met all the required conditions in terms of the local codes of practice, the local material, the local design parameters. So the structural engineer will perform analysis and optimize the building to ensure that maybe things like the seismic analysis, the wind loads, and what are you. Then he updates the structural designer. So that was supposed to be two-way. So the structural designer starts by defining the physical model in terms of the elements, the nodes, just the overall analytical model. He shares the same with the structural engineer who reviews it, applies the various loads and optimizes the design, then shares it back with the structural designer. And the process repeats itself up to a point where all of the two are okay, that the design can proceed to the next stage. So that then they compare the changes, approve them, using one integrated model where you can be able to see the physical model side by side with the analytical model. And that basically happens within Autodesk Revit. So the first phase of the design, that's the work which happens between the structural designer and the structural engineer. So identification of the structural material, definition of the structural model, and this is with respect to the architectural model, where if you have got time maybe to look at the interface of the Revit, you'll be able to see that you can automatically directly link up architectural model, then start defining your structural elements with respect to whatever the architect has identified them in terms of their location, position, and even sizing sometimes. So immediately that's done, you can automatically select to be creating your analytical model corresponding to the physical model that you had created from the architectural model. So what that first phase there shows us is the physical model and the analytical model. And as we remember, an analytical model basically gives us the nodes and the joints, plus the various support conditions and boundary conditions of the model that you are proposing. Then after that, the structural engineer will define his loads, so that the dead loads, the live loads, and also including the dynamic loads, that's the seismic plus wind loads. Once all those parameters are identified and are agreed between the structural engineer and the structural designer, they can now proceed to the next stage, basically where they perform analysis of the same. And this now happens within robot structural analysis professional. So, and again, it's a dynamic or it's automatically interoperable, where whatever I worked on within Revit in terms of my physical and analytical model, it's just a matter of a click of a tab, and then my analytical and physical model will be sent to the structural analysis platform within Robot Structural Analysis Professional, and then more detailed parameters can be defined in terms of the local code conditions that you want to use, in terms of the site conditions, whether you are going to use like for those who have used BS to perform their wind load analysis, we know that you can either use the tunnel effect to stimulate the wind load on the building, or just defining this equivalent static load on that particular building that you're working on. So all those are possible within the interface of robot, where you can choose the specific design parameter and analysis condition you want to use on the model. Then the building will automatically be analyzed, and you can be able to generate your loads from it. So once that is done, again, you can go back into Revit and review your model to ensure that your boundary conditions and all the specified and defined parameters remain the same. Then after that, you can now start comparing the changes and sharing your design through the BIM 360 docs. So we now look at how those one works. So just a short video to illustrate how that works within Revit. So we are having our physical model, which has been defined with respect to the architectural model. So we have defined all our structural elements, as the beams, the slabs, the foundations. Then we can easily translate that into our analytical model, where we're basically looking at what we have in terms of the support conditions, the boundary conditions. Then we can now publish our model. So publishing is basically the process that we use to share our design intent to whoever is interested in it. So in this case, it could be the structural engineer. So publishing it, then you go into the BIM 360 to upload your intended design to the respective person. So in this case, so from the drawing, as you can see that the structural engineer in this case, the normal way we do this is to either print it to 2D PDFs or start sharing it within our local area network, or using the FTP which, as I said, that if you print the 2D, 3D model into the 2D, we lose a lot of information in terms of what we want whoever is interested looking at our design to receive. So when you use Revit software, we can see that the physical model is the same model which also has, or which is also associated with the analytical model. And if the structural designer or engineer creates both the physical and the analytical model in the Revit, the same data remains within the same platform. So you don't need to be using or translating from one platform to the next, like maybe where you are drafting your layouts or the GS or AutoCAD, then performing analysis on another third-party product. You find that there's usually that loss of information, and that a lot of time is also wasted when translating from one to another. Or if you're doing your 2D sketches or 3D sketches of the analytical models manually, a lot of information is usually lost in that process. And also it's time consuming in terms of when you want to deliver the project within a specified timeline. So then after that also, you can now extend that. Sorry. So once you have reviewed your analytical model side by side with the physical model, so the next you now extend that to the BIM 360. So basically you saw in the previous slide where you are publishing it onto the BIM 360 platform to enhance sharing of the design documents. So the extended structural team can now review whatever they have come up with together. They don't need to sit up on one desk and start looking at this. So this utilizes the power of a cloud collaboration between the two using BIM 360. So when the project teams have the right information at the right time, this can happen very, very fast. And remember, sometimes when sharing this design information together with the corresponding structural analysis report, it takes time when you want to send it into PDF, then start uploading it to the instead design team. So BIM 360 Docs lets them publish, manage, review, and approve all drawings, documents, and models in time, anywhere. So once they have confirmed that all the documentations and the design that they intend to have is complete, I say that they can automatically send this into robot and start running their structural analysis. So and again, it's not just a matter of structural analysis in robot, in terms of even visualizing, simulating your loads and the impact that they're going to have on the structure happens quite easy. And you can easily run the overall structural analysis of the project and start looking at which kind of loads you're looking at, what are the bending moment diagrams you are having in terms of the loads, the shear forces. And this also integrates together the dynamic loads, which, as I said, that you can easily specify the code of practice that you want to perform those analyses with. Then you can be able to generate the results. So not only is it just analysis again, you can start optimizing, like in case where you're looking at a structural element, still as the one you are seeing currently, you can start grouping your structural members together. And the ones that, like, for example, this particular floor, you see that the beams are likely to be of the same. You just choose each of them and then start optimizing. Then the product will give you the ones which are likely to perform better. And it just ensures that you don't over-design or don't under-design in terms of the structural integrity of the model. So it will give you the most recommended structural element for that particular members that you have selected. So you're supposed to choose whether you're going for the most optimum, over-designed, or under-designed, and you go to select the one to apply to the overall structural element that you had selected. So all those are possible if you integrate that workflow between structural analysis professional in robot and the physical and analytical model that you had started up with from Revit. So then after that, you can review the final documentations. That's basically the one which now integrates the structural analysis report. So you can now update the changes that you had generated from robot. You update it back into the BIM 360 for communication. So when such design changes and analysis have been completed by the engineer, the information can be brought back into BIM 360 easily, just by a matter of either dragging and dropping or using the normal add or file path to update the entire design team that's connected in the BIM 360 platform. So once they are here, the results can be easily stored and explored by the different design team. The users can explore and document the results and make effective design decisions without having to wait for emails that have not been sent by their team member or ensuring, or just some overall delays which could have happened on someone's maybe inefficiency as a result of not being able to send a mail or update the entire design team. So in this case, everything is set up on the cloud, and if there's any design review which needs to be happening, whoever received the design information can download it and make reviews. Once they have made their review, they can upload it back into the BIM 360. And immediately that is done, the entire design team will be notified of the latest or current changes within the design process. So this results into very high efficient design process since the information is shared in real time. So viewing and consolidating the design results, updating documentation, making further effective design decision is very, very easy. So once the Revit model has been updated, the analysis and code check process is also very, very easy because the dynamic integration between Revit and robot is still maintained as long as the file paths and the metadata of those different design models is not changed. So that integration still happens automatically, where reviewing and making design changes is still very, very fast. So once the design has been reviewed, you can now start comparing those changes again. So this is where the structural engineer had received the data from the structural designer. They can download it back on their PCs by accessing them from the BIM 360 platform. So within the BIM 360 platform, there are tools which can allow the team members to do automatic documentation version compare. So you just click on compare, and it will give you the changes which has been made on the previous model compared to the one that you are receiving as of this particular time. So you'll be able to see that on this date, or maybe this version 1 compared to version 2, this particular element was maybe having this structural section, but with the latest update, the designer reviewed and made this change on it, and right now it is maybe IP270, previously it was IP240. Or if you're using the BS sections, it should have been maybe the UB something, being updated to the UB something. So that makes the design review or getting design changes very, very easy. You don't have to be browsing through the entire 3D model to start identify the various changes which have been made compared to the last time you looked at the model. So in this case, just a matter of clicking on the compare, and the BIM 360 will be able to highlight to you the various changes which has been made over the time. So then that now takes us to the next workflow. Now that you have created our concept, you have shared the design to the different design team. So basically looking at the structural designer and the structural engineer, we can now look at how we can connect our deliverables to the project team. So in this case, we're going to look at the connected delivery. So basically, again, looking at now, we now start integrating the fabricator or the contractor. So we are assuming that we have done all our design. We have checked all the design requirements in terms of the analysis, the loads, and what have you. We have generated our documentation. So we now want to start integrating the contractor or the fabricator who may sit with us in the same office or could be in the contractor's office. We now want to start integrating them together within the process. So the structural engineer still defines the connection if it is a structural design. So they have analyzed and they now want to define the various structural connections for the elements. Once they have defined, they share the same with the designer. The designer creates the connections as per the specifications that the structural engineer has given him. Then he shares that with the fabricator. So the fabricator is going to generate for us the shop drawings. And once the fabricators receive that information, they will create those related deliverables in terms of fabrications and share it with the entire design team. So this still happens again in the same products that we had looked at previously, but mainly within Revit. So Revit has inbuilt tools for doing structural connections. So we know whether they're going to be the gusset plates, the holding down balls, and what have you, all those are already present within Revit. So you're just supposed to specify them based on the kind of joint you're looking at. Then you will automatically be able to apply it to that specific connection that you want to design. Then after that, the detail required will be done by the structural detailer or the structural designer, who then communicate that intent to the fabricator using BIM 360 again. Then once the fabricator has done his required bit, he can share the same back with the design team still within the BIM 360 platform, and they'll be able to compare and see the changes or the exact documentation that has been produced by the structural fabricator. So this can be done to different level of details. So amongst them are the level of detail 200, 300, and even 350. So basically the amount of information or the kind of details that you want to receive based on the various standards and parameters that you had agreed on at the start of the project. So again, we'll just look at shortly some short previews of how this happens. So as I mentioned, you start doing your connection design within Revit. So for example, you just go to that specific connection. So you choose the two elements which are joining together. Then you go and choose the correct joint type that you want to use. So like in that case, I want to use the angle connection. I specify the bold parameters. Then if I add an image which basically shows or illustrates how that connection happens, I can attach it. Then I'll select all other elements which are likely to have such kind of connection. Then that's what I'm proposing to have. Then I will share it to the structural detailer using BIM 360. Then through the BIM 360, the structural detailer will be able to get that information just with the first of having a preview of what has been proposed, still within the same platform. So you'll be able to see the symbolic connectors in the drawing. So maybe you could color code them. So then you can maybe just specify that as an issue where you give him maybe I want this specific designer to look at it. I specify the parameters. I can now tell him to start adding the specific type of connections at the various joints within the model. So if maybe now I can now attach the image that I'd used. So this is the specific image how I would want those kind of connections to look like on the final detail. So those are the sketches, how I want them to look like. So those are my angle connections. Then I'll click to publish my request. Then automatically when I do that, the structural detailer or the structural designer will receive a notification on his side. So what he needs to do is to again now also access it. So you can see he receives a mail on this email that have requested him to do a particular task. So you can go and view that task on BIM 360 platform. So you can see the information that you are requested to add an angle connection. And this is how I'm looking at the details. Then you can now download that file, open it in his Revit. Then you'll be able to see the specific connector symbols that are indicated. Then start providing the specific details in terms of the bolts, the plates, if there are going to be some welds, the specific grade of the bolts that I'm going to use. So this again happens automatically within Revit, as you can see. So once you have selected it, just to ensure that they meet the required detail level that the structural engineers have specified. Then from there, you can automatically start producing the documentation in terms of the details just by cutting the sections and plugging them to the relevant sheets. Like that's the holding down bolt with the corresponding base plates. So it's very, very easy when you work with this kind of workflows to generate your documentations in a multidiscipline team. So for example, at this stage, you're still looking at the two people, that's just the designer and the structural engineer who is giving the specifications. So the structural engineer specifies, the structural designer gives the relevant details. So once those details have been provided, the next stage is now to share that with the team, where he's going to publish his parameters that he has changed onto BIM 360 in form of sets. So sets are just like the sheets that he has made changes on. So you go back and upload it onto the BIM 360. And again, immediately does that, all the design team, all the design members will be able to see the current and the latest version that has been published. And it now it now notifies them that he has done the information which was requested. He has done all the joints. So the physical model now has the joints, as you can now see within the BIM 360. You can now be able to see those. So I can now close that issue and mark it as checked. So the structural engineer can now review the model and be able to see it now contains the connection. So the communication, the back and forth communication which happens between the design team is very, very easy. So in this case now we are communicating our design intent to the fabricator to be able to generate for us the shop drawings from whatever we have done, still using BIM 360. So once I've sent that, the structural fabricator will receive the information. They'll go and open it and export the model from Revit to structural steel. So remember, structural steel is the tool that we use to do our structural design and shop drawings in an AutoCAD platform. So it's more like similar with the AutoCAD platform, but it has tools which automatically allows you to produce your BOM, the bill of materials, the shop drawings, and the prefabricated elements in terms of the detail that has been specified by the designer. So then he again uploads them up into BIM 360 to enable the design team to receive his fabricated or shop drawing models, both in 2D and 3D. So it notifies them again via text, the details that he has provided and the activity that has been happening over that period of time. So again, the information will be received by the design team, who will again log in onto their BIM 360 to receive the various shop drawing and documentation which have been provided by the structural fabricator. So then after that, we now connect the entire design team. So previously we just been looking at the two people, then we have added the third person, which was the fabricator, who was generating for us the prefabricated elements. So we now need to bring in the architects, the MEP guys, to now start working on that connected team platform. So basically now we want to start collaborating with the architect just to ensure constructability, because sometimes the models that have been proposed by the structural engineer could be clashing with the various architectural elements, like maybe the windows, the doors, or sometimes can also be clashing with the MEP elements, where maybe there's a duct which is cutting through a beam somewhere. So to ensure that happens seamlessly, they need to now start working on that collaborative platform. So the architect comes in as the project manager. So the first two happens the same way, where the structural engineer communicates the design intent to the detailer. So the detailer now does the same to the project manager, which is in many cases is usually an architect. So the architect will review the model, feedback to the structural detailer, who then feedback to the structural engineer if there is any need. But all of them can get such kind of information still within BIM 360. So the workflow remains the same, working still within the Revit and BIM 360. So the structural fabricator or detailer has already done his bit within Advanced Steel, producing the required documentations. So he can then collaborate within Revit by sharing that to the team. The team will be able to download and see whatever they have been doing within Revit, so that the integration between Advanced Steel and Revit is also dynamic. So they just need to upload and convert it into a file format which Revit understands. So the integration is also direct and very, very easy without having to worry about saving into one file format to the next. So he shares that design intent in BIM 360. Then the architect will go and log in on that BIM 360 to now receive the design intent from the structural team. So that's an architect now going to BIM 360 and starting to perform his overall review in terms of the joint, the overall structural elements that has been provided by the structural team. So this can be on a 3D platform. So those are our prefabricated elements with the correct structural detailing which has been done for the prefabs. So just looking at it, so the architect is reviewing in terms of the door position, the window position, whether it's going to be a potential clash with his proposed architectural model. So once he has performed this review again, he will now feedback to the structural detailer if there is any changes by publishing the same to BIM 360 and identifying and marking up the issues that he has identified within the model. So he communicates that. The structural guys go back and receive the same. Still within BIM 360. So they'll go to the specific model that has been reviewed by the architect or the project engineer. So if there is any change, so there is a particular issue which was identified and marked up by the architect, like the reinforcement there, which was likely to clash, maybe to cause an issue with the door frame. It marks it up and again notifies the design team to review it accordingly. So you can see within BIM 360, not only can you just review, but you can go to the specific reinforcement bar within the model and even mark it up as a potential issue. And from the, after having marked it up, you can create an issue from it and ask the detailer to review it accordingly. So change the diameter of the rebar. But in this case, again, the structural engineer may oppose or agree with the change that the architect is proposing in this case. So like where the rebar diameter is likely to interfere with your structural integrity of the model, that change may be denied and you may propose to proceed with it as is. So those are the various kind of level of collaboration that we're now looking at when you work with the BIM 360 together with Revit. So the communication and the design project review, the project review happens very, very quickly and fast between the external team and the structural team who sits somewhere together. So in this case, you don't need to be calling for different design review meetings to just have an understanding of the constructability issues which are likely to result from the project. So you can even cut up the model into 2D and 3D section views to start at looking at the issues which has been resolved and the ones which are still pending. So then he communicates that, immediately uploads it, the same happens, the structural team receives a notification, and they will now go and get that specific issue which was identified by the architect still within BIM 360. So that happens very, very fast. Then they can now go back in Revit and start making the corresponding changes on the specific element, upload it back into BIM 360. Then the architect will automatically receive the updated model and start doing the version compare. That's version 1 or version 2 or 3 and 4 to just be able to see that the change that he requested has been correctly impacted or not. So such kind of collaboration is very, very easy, and we know very well that currently the way we work, it is still very, very inefficient. Even receiving a design change or RFI from a design team member usually takes like weeks. If we work with BIM 360 and update happens automatically, the team is saved in terms of performing the overall design review and requesting for such kind of changes. So basically, that's what I intended to show you today, how you can use the various tools within BIM 360 to collaborate. So sometimes also, I will not show this because I realize the time is not on our side because we started a little bit later. So just to show where the two now works together, you want to request as a structural engineer an update from an architect to maybe move a wall or change the position of a wall within the architectural that you have been working on. So if you work with the collaboration for Revit, that is integrating the BIM 360 design now, you find that you can easily make a request to make a change within an architectural model based on the structural element that you have defined. But if that doesn't work correctly, sometimes you may be forced to request for an information or a permission from the architect prior to making such change. And immediately that permission has been granted by the architect, you can now proceed to define the various structural model. And this works perfectly well using the collaboration for Revit together with the BIM 360 design. So I'll just bypass that last slide to go into the summary part. So just looking at in terms of summary or the overview of what we what this kind of workflow can provide you with. So you find that if you integrate such kind of entire workflow within your design process, the AEC collection provides you with a tool which does multi-material design. So as we had seen within Revit, you can work with whether it is reinforced concrete, structural steel, or even composite, automatically joint analysis and connection design. So doing analytical model side by side with the physical model was very, very easy. So it makes it easy for the structural engineer to explore the different parametric conceptual design, collaborate with the other design stakeholders, that is the structural design in this case, and at the same time, keeping all the designs within the same environment. So where we don't do an analytical model somewhere else, then integrating it with the physical model in another platform. So you see that documentation, modeling, analysis happens in one platform where you're just supposed to be translating from one phase to the next. Also, we saw where it was very, very possible to perform analysis and verification by just moving your structural model plus the analytical model to the next phase or next platform, which automatically does your analysis by allowing you to define code-based standards to be able to visualize and perform analysis of the model that has been defined. So conducting advanced analysis, visualizing detailed analysis, pulling out the reports, and even optimizing, as we saw that you was able to optimize, because the product could specify for you the most optimum design, under design and over design. So it was upon you as the designer to choose the one which will meet the design requirements. Also, it was possible to even guarantee safety because we said that you can simulate wind, you can simulate load, plus even seismic, that's earthquake from the design model that you have created. So then for the detailer, it is possible for them again to carry out their engineering design intent and detailing quite easy, optimize their detailing, merge the design changes very, very fast. That is through the integration of the BIM 360, where people review the project, update the design team. Also, performing structural detailing within the 3D model is very, very fast. So integration of the shop drawings, as we saw, that was able to, the fabricator was able to easily create shop drawing using advanced steel. And the same also now allows us to even integrate prefabricated models within our workflows. So I'll just now stop briefly to take one or two questions before we call an end to this webinar.
Hi, thank you so much, Elijah, for the presentation. So what we'll do is, for all the questions that you guys have, please do send us an email on the follow-up email that will be coming through shortly, and we will direct those questions to Elijah and they will be answered correctly. So for now, thank you so much, guys, for joining us for this webinar. And we have come to an end, and please do send us an email with any questions or any comments that you would like. And thank you so much. Enjoy the rest of your day.